It's a pleasure to be here, and certainly in such a distinguished company. I think, like most of you, I'm really looking forward to this panel and finding out what our panelists think about the evolution of this exciting technology. So why don't we start with a little introduction? So maybe each of you could talk about your current role in machine learning and AI, and what do you specifically do? Are you in strategy? Do you actually code? And perhaps what was the path that led you to that role?
Sure, I'll start. Yeah, sure. My name is Michael Recce. I'm the chief data scientist at Neuberger Berman. So my original background was in math and physics. I did graduate work there. Then I ended up a professor teaching computer science. Actually, I have a PhD in neuroscience also, so I was teaching medical students about the brain. So, so then I helped my students start a couple companies, one analyzing bank transactions to find fraud, and the other one, these are relevant because you'll see, we talk about data in a moment. The other one analyzing online activity to decide what ad to show you in real time. So then I went from there to Point 72, where I was chief data scientist, and then I was chief data scientist at Singapore Sovereign Wealth Fund, GIC, and then now at Neuberger Berman. I describe the sequence as too hot, too cold, and Goldilocks. But what we do is basically at Neuberger Berman, we get to have our own investing book. We provide insight for the investing teams. We analyze data to determine, to get a clearer measure of intrinsic value of investable companies. So when we do that, sort of as like a central research function in the firm, and provide information to the teams. And we all code.
Thank you. So my name is Lawrence Black, and I work at Barclays Bank. And at Barclays, I run a team that design and develop passive indices. We have probably about 2,000 indices, probably about $40 billion under hedge, and 50 people dedicated to the design of our indices. You know, and our clients will range from a hedge fund, or a private bank, an insurance company. So what we're trying to do is figure out how can we use AI and machine learning and incorporate into our indices, and then pass those premia onto our clients. You know, and for example, everyone can offer a value index, so we're trying to figure out how can we use AI and machine learning to offer something that is really unique. So I guess I'm involved in the business strategy and sort of the high-level design of our investment strategies. And then prior to this role, you know, for my sins, I was a fixed income trader, and then probably about 10, 15 years ago, I moved into the design of indices. Over to you.
Thank you. My name is Ed Mitby. I'm the senior AI engineer at Vanguard. My graduate school training was in basically simulation, optimization, Markov chains, that type of thing. You know, a while back, before reinforcement learning became, you know, more cutting edge. I've been in the discretionary trading world for, you know, probably 15 years. As you know, AI has really bloomed, and just fairly recently, as far as the, you know, the history goes, I became very interested in this stuff because this is basically what my background is in. So I plunged into deep learning and now reinforcement learning, and I'm very excited about it. And like I said, I'm an old school Markov chain person, so the advent of reinforcement learning is very exciting to me. At Vanguard, you know, Vanguard is, I think, uniquely placed in the world in that, you know, there's a lot of work to do there. So I have a pretty broad mandate to supervise and initiate projects. So we've done everything now from, you know, factor return projections, you know, can a machine learning model do better than the classical, well-documented, you know, time series models? You know, there's a lot of stuff on the business side that can be done, and, you know, in terms of structured data. And, you know, and I'm working on a lot of things that I can't really talk about, but it's, you know, there's some very cool stuff going on, and we're making a lot of progress. So it's very interesting, and I'm pretty excited about it. And, you know, and there's something new that comes along every day. So, you know, this is great.
Okay, very good. So I'm a startup person, and my job is to keep the industry on their toes. So in the spirit of that, we're going to do a quick-fire Q&A. So we're going to ask very quick questions, and our panelists will have 30 seconds to answer. So let's start with Michael. Michael, an asset management firm of 2029, what do you think it will look like?
It'll have fewer floors.
Lawrence, what do you think the unsolved problems are in the investment management industry that AI will have a role in?
You know, right now, I think it's really how do you combine that human intelligence with the AI, and that's something that we've struggled a lot with, and really marrying them together to form the perfect, investment thesis robot would be great.
And Ed, so since we're all in the business of predictions, what are the hottest AI technologies that will dominate 2019?
Like I said before, I think it's going to be reinforcement learning. I mean, that's where all the cutting edge stuff is happening, and it definitely frames the problem in a different way. It becomes, instead of a pattern fitting exercise, it becomes more of an optimal policy exercise, which, as far as financial markets go, I think that shows a lot of promise. I think, my favorite analogy is, could a good deep learning model, could that have predicted the subprime crisis, right? When all of your data indicated that nothing had ever been defaulted ever, and a deep learning model is just, it's nonlinear function approximation based on the information it's given. And maybe it would have, maybe it wouldn't have, probably not. Could a Markov chain predict the subprime crisis? Yes, and they would have done very well because the steady states showed everyone, was going to pay their mortgage. But, and the way defaults worked is once you get into the state of where you're behind or 60 days behind or 90, as you go down that progression, it becomes very hard to get back to the current state. And it didn't take that much complicated Markov chain model, and anyone is welcome to do this, to show that, after a couple iterations of massive delinquencies, the steady state becomes massive defaults. Reinforcement learning now, which is combined with deep learning, has become very powerful. And like I said, that's where all the cutting edge stuff is. And you're seeing optimal liquidation models based on it, and a lot of stuff outside of finance happening with it. And everyone's seen the Boston Dynamics robots and things like that. So I think that's really going to be an area of extreme interest for people. And I think it's pretty exciting stuff because it definitely frames the problem in a much different way and allows you to apply many useful parameters to something instead of just fitting a data set.
Fantastic, thank you. Okay, so let's talk about problems. So obviously we know that this technology has enormous potential, but also every year we hear about epic failures. 2017, unfortunately, was a very sad year where we had a death caused by a self-driving car. 2018, looking a little better right now, and probably the title goes to the false predictions of the World Cup that several prominent investment banks did out there. And obviously, we all hear about the performance, the quant fund performance problems this year. What keeps you up at night? What do you think are the problems with the technology that we have, and then what do you think the industry can do to solve them?
So I think the problems. I really don't think the technology is the hindrance. I think the hindrance is mostly cultural. But certainly the challenges in the data. The challenges are really that we're developing new algorithms. The algorithms are harder to develop and they're harder to understand. But I think that we have a lot of runway with technology and the algorithms before we actually really have things that are blocking. So, but I think the cultural challenges are bigger, and they're the ones that keep me up.
From my perspective, I'll give you a couple thoughts, and especially from some of the stuff that we've seen. So, apart from the culture, I think that's absolutely right. I think for us, data cleanliness and consistency, and is a huge aspect. And then optimization and overfitting and figuring out the right models. And I'll give you two examples. Firstly, we worked with a machine learning firm, and they were trying to figure out a digital model for a company. And it was very ambitious. They were trying to evaluate 30,000 companies. And we would look at the model and we'd get a score for Amazon and Walmart and KKR, and it all looked fine. And then we would go look at the top 10 companies, because that's what we wanted to trade. We kept on finding 2 mortgage REIT companies. And we were like, this is not a digital company. And they were like, no, it's just a bug. It's just a bug. And they just couldn't fix that, right? So it's, and then it's the over-engineering, optimization. And then, at Barclays, we're trying to be outward looking and partner with a lot of data companies and AI and machine learning. So we're having a lot of people that come in and talk to us and show us their wares. Another example is, in fact, just earlier this week, we had a company that came in and said, we've got this great back test. So we said, wow, looks interesting. Let's talk about it. And then, so we got talking, and then they said, well, we did the training data. We had training data from 2015 to 2007 to 2015. But then, they showed us the results from 2007. But, the data in 2015, they couldn't get to, have an investment thesis in 2007. So, it's just like point-in-time data, getting the data, understanding it. Another one is like timing lags. So many people forget to incorporate timing lags, that it's impossible to actually make the whole product tradable and scalable. So, I think there's great promise, and it can certainly help in maybe allocations and portfolio frameworks, but it takes a lot of understanding to understand what are the actual pitfalls once you get to the nuts and bolts of using all these technologies.
Thank you. I would say that I totally agree with the cultural thing. I would say there's a fairly widespread misunderstanding on what these various algorithms can do. On the one extreme, I think you run into people a lot who think that a deep learning model can solve just about anything, regardless of how uncorrelated the data is or how messy the data is. And as far as solving a massively uncorrelated data set that looks like a complete mess, a deep learning model can do much better than, say, multiple regression. But I think the danger is that people overestimate what models can do at some point, and that just leads to, what I've seen is it leads to a vicious cycle, because then they get disappointed and then they say, well, this new stuff isn't working for me. But the reality is the problem needed to be framed in a different way to begin with. So I think that's impeding a lot of companies. This is what I'm hearing. And it's everyone in the world is interested in AI, and you do have a lot of predatory people out there pitching things that are ridiculous, and a lot of consulting companies and that type of thing. So a lot of it has been pretty brutal in terms of the cost to people. And so people are a lot of people have lost, money and project time and that type of thing. But I think at this point, these models have proven that they've worked for the things they're supposed to work on. There is no proof of concept anymore, right? And so if you're not doing these things, you're definitely going to fall behind. This was a much different situation 3 years ago, where the first movers, in a lot of cases, it did not work out well for them. So, and I think it's pretty exciting, because this stuff is moving very quickly. And like I said, the most cutting edge stuff is probably in reinforcement learning at this point. It's a very different paradigm, I think, from structured data analytics with deep learning. But this stuff is moving very quickly, and it's pretty exciting to be on top of that.
If I could just add, yeah. I mean, I was trying to answer the question about real technical problems, but I absolutely believe that the industry will see a lot more heat than light for a while. There's lots of people who want to apply deep learning to lots of things that. I often will ask them, "Have you tried regression yet?" And so they want to try deep learning first on problems which are actually quite a bit simpler, just because it happens to be fashionable. And really the problem is what I would call a bootstrapping problem, which is that it's hard to know what you don't know when you're starting out in a field, and there are lots of sort of more noise than signal in resumes and so on. And I think firms are hiring people and trying to invest in something and move forward in something. And I think we're doing deep learning now. Oh, really? So it's a natural when there's lots of excitement, and particularly in an industry where if you get it right, you make a lot of money. But I think that we're going to have more heat than light for the short term.
Well, I think this is a great segue into the next question that I actually wanted to ask Michael. So we hear a lot about the shortage of talent, of folks who understand data science and machine learning. And there are different numbers that are thrown out there. I read somewhere that there are 10,000 PhD level specialists across the entire world, all fields, right? So healthcare, and we're competing with all fields out there. How do you attract talent in this environment? And how do you attract talent, and how do you retrain your domain experts to actually become at least the translators between the data scientists and the business?
Yeah, thanks. So I mean, I used to be in the advertising space, and one of the things that's happened in advertising is internet advertising has gotten really good. Mark Zuckerberg was recently in front of Congress, and partially it was because of the Russian ads, but partially because we're all feeling a little bit uncomfortable about the accuracy of advertising. So when people say, well, how do you use machine learning in finance? I say, well, look, you know that Mark Zuckerberg's firm is using machine learning on messy data in order to decide what ad to show you. And literally, it's the same problem. Because if I know what ad to show you, and I know that across all products, services, sectors, geographies, I know which companies are winning in the marketplace, and that's not currently priced into the market. So you can use the same analyses you would of people's behavior in order to figure out, what their intent is to buy and what products they want to buy. So I pitch to those folks because those people have been working with very messy data with the right type of technology stack in order to figure out how to show advertising. So I say, look, let's say you get the best job in the world at Facebook. What are you doing? You're doing machine learning in the cloud on clickstream data. What could be better? But at the end of the day, you're buying an ad. An ad costs a teeny fraction of the cost of a grain of rice. I say, come to finance. Do the same math on the same data, but the positions are 10 orders of magnitude bigger. Since the positions are so much bigger, you can afford to make the math better, the data better, and you get paid more. Well, the challenge of stopping them from entering the space is that if they go to Facebook and Google, they get to be creative folks who go build new interesting things. If they come into finance, they do work orders. Fix my email, put a phone jack here, and write this piece of code. And so, we have to actually adjust the way that technology works in firms in order to actually create a culture which allows people. So at Neuberger, we get to have our own book. So we get to actually look at how we would use algorithms and how we would use data in order to do a better job of investing. And so that's really where what's going to make this work is bringing those folks in and empowering them to be able to. So it's part of that. That's the way that you attract people. But they're going to come in with the right tech set of skills, and it's going to be a new set of folks from the way that people were hired in the industry before.
Well, I'm definitely going to borrow some of these tips. Okay, so Ed, what are the engineering challenges of actually deploying AI in practice? We hear a lot about very successful school projects, but then you deploy it in real time and nothing works. Data is messy. Computing power is expensive. How do you deal with that, and what tips would you give to people in terms of practically deploying this technology?
It reminds me of a quote by Professor Peter Carr. And Professor Carr, if you're out there, I've never met you, so I don't know if you're out there or not, that he has at the beginning of the new Prado book, which I thought was really interesting. He said, to err, I can't remember it exactly, to err is human, but if you really want to mess things up, use a computer. He uses much more colorful language than that in the book. But there seems to be, especially with a trading system or an execution type, an algorithm for execution, deploying those types of things. If you mess that up, and medicine's the same way, it's not like you're at Netflix where you recommended Police Academy 3 to people, where they just move on to the next thing, right? You just cost a bunch of money, or someone died. So back to your point on the tech culture versus the financial culture, there's a much, the penalty for being wrong in finance, especially with trading execution, is massive. So as the algorithms get better, in algorithmic trading, it's definitely advanced over the last couple of years. As they get better, as the algorithms potentially get more complicated, you really need to be clear on what exactly you're doing. And so I think the advice is, and just in terms of project pipelines, I think what you want to do is start small, right? And you want to do it in small steps, and you want something to work extremely well before you make it bigger or encompass more features or something like that. And when you get to deployment, you definitely want correct A/B testing. You don't want to deploy something completely live for no reason, right? So it's definitely a process, and it brings up a lot of interesting issues from a legal standpoint, because how do you define this model to someone who doesn't quite understand it? And if there's a mistake, who's to blame? There was a fairly big fine recently to an asset manager because their models had gotten, somehow someone had done a translation between languages, or I don't know the details, but the fine was fairly big because basically what the funds were doing did not match up with the prospectus. So, people have to be well aware of what they're doing. You need to understand what you're actually doing, and I do think a lot of these algorithms are not that complicated. Most of your machine learning algorithms, they've been around a long time, and a lot of them, at least one iteration, can be done in a spreadsheet. I mean, you can do a gradient boosting algorithm and do at least one pass on a spreadsheet and show it to people. Obviously, when you're doing it in reality, you're going to do, thousands and thousands of iterations. But I guess the whole point is, a lot of these algorithms are not that complicated. You just need to be clear on what you're doing, and you need to take things in very small steps and make sure everything's right before you start building onto the next step.
So we want to leave a little bit of time for Q&A, but before we move on to that, let's end on a good note. I mean, after all, we all do this for a living. What are your hopes and dreams for 2019 in terms of implementing the technology?
Me? Ah, right.
Yep.
Okay. So I think there's a whole new field which is some people call quantimental, but I think it's combining the way that fundamental folks think. Historically, quant models looked backwards in time at mispricings, and forward in time predictions were based upon spreadsheets and head scratching. But we can build computers that play Go and chess, and so I think we could also build computers that actually do fundamental intrinsic value prediction for future years. And I think that it's going to be an interesting way of combining sort of computer automation, insight from data, insight from the way that people built valuation models in the past, and I think it's going to create a whole new area, probably as big as the quant revolution was.
From my perspective, I'm glad you didn't say 2029, because I think that's a lot more difficult to predict. But from a 2019 perspective, I think you're hopefully going to see, the best of AI and the best of humans coming together. And I'll give you some examples where we use it and where we see some of our clients using it. For example, one of our clients was telling me last week, they run a systematic portfolio. The managers have discretion, but what they've implemented is an AI sort of filter that, if he's going to sell a stock that's been downbeat, last time you sold a value stock, the outcome was X, Y, Z. Are you sure you want to sell the value stock? So I think it's applications like that where, it's really using AI to add value to the investment hypothesis or help with some behavioral finance issues. But you have to be careful. I mean, our biggest project we have at the moment is sort of taking Twitter data and using some various techniques on that data. But the interesting thing for me was, our investment thesis has totally been turned around. We went in there thinking that a stock that has a lot of tweets might behave in such a way. It's totally flipped. So it's not immediately obvious, and you really still need that human input. But I think the combination of humans and AI together will be really good for 2019.
Thank you. I agree with all of that. I think that there's going to be a lot of exploration going on. I think there have been on the quant quantitative investing side, I think over the last couple of years, there are several strategies that are fairly crowded. Factor investing, I think, is fairly crowded. And I think, especially with this most recent correction, a lot of people are going to be rethinking how they, what kind of a strategy should I be deploying? What should I be actually trying to do here? Can I use these algorithms to come up with something more forward-looking rather than backfitting some kind of a profile? I think there are very large opportunities in multi-asset tactical portfolio allocation in terms of optimization. And again, just because I'm an old school Markov chain person, real reinforcement learning seems to have some very promising things you can do in that space. And so that's what I think. I think people are going to be looking beyond a lot of these strategies that are well accepted and well researched and well documented, especially on the academic side, and looking more into how can we push this envelope, where can we add this value. Any kind of even semi-linear model out there that does anything can probably be upgraded to some better algorithm at this point. So I think there's a lot of opportunity to explore, maybe not purely some equity like stat arb model. I don't think that maybe there are ways to improve that, but I think people are going to be looking to other aspects of investing, like multi-asset, or macro trading, or different asset classes. How do you rotate those around given cyclical market conditions? And I think like I said, we've been in a fairly static market for quite some time, and just in the last couple of weeks, that has kind of shaken some of those theories that a static market can last forever. So I think there is going to be some very interesting things going on in how to apply these. How to apply these new technologies, and it's I'm pretty excited about it, actually.
Fantastic. So now we'd like to turn to the audience, see if you have any questions.
How you doing? Sentiment analysis. How does that get incorporated into what you do is on a tech vista? Do they mine it?
So I'm happy to.
Yeah.
So sentiment analysis, in a broader category, I would say natural language processing. So in the early forms of sentiment analysis here's my list of adjectives. There are lots of issues with early forms. So if there's a tweet that says, "I love my new iPhone, my mother hates it, much better than my horrible BlackBerry," what's the sentiment? Is it positive? Is it negative? And so the academics using there's some deep learning methods, but there have been lots of advances in phrase analysis. In my world, we use natural language processing, but we don't use sentiment analysis, and we don't look at sentiment. Sentiment is news is what drives temporary mispricings in the valuation of stocks and value in price, but we look more at the long-term value. So we look at transactional type data, things that talk about who's winning market share, who's losing market share. But we also use natural language processing. So sentiment analysis is a subset of a broader category of tools.
Yeah, I have a perspective. We've looked at a couple of vendors, and there's a range. For example, there's a company called Prattle who can provide NLP, and they've got very sophisticated linguistics to really pick up the meaning of what someone is saying, through all the way to some vendors where you actually sort of code in the words you want, and then you have to spend a lot of time on the machine learning. And then so we've looked at that. That's really around earnings. But from my seat, earnings drive a huge amount of price movement. So that's very interesting to us. That's the first thing we've looked at, and then as I mentioned, we've looked at Twitter in a lot of ways. We're trying to figure out if there really is some sentiment there, and I can't find anything. I can sort of find negative sentiment, but not on the positive side, where we've been able to distinguish anything from just this sheer noise.
Yeah, I would agree with that. Sentiment analysis, at a basic level, if you're scanning, whatever publications for, hot words like crash or, earnings beat or, all these keywords, kind of analysis I've done personally, and you know, the people I know a lot of people who invested in this have done it. It seems to be very mixed. You know, it's you could almost replace all the NLP with, you know, how much the S&P has changed in the last 5 days, because, you know, your classic retail investor tends to panic the most at the right time, and they get the most bullish at the wrong time also. So, you know, those, you know, what is their sentiment? It's almost, in some ways, it's almost a contraindicator. So it's, you know, so not only, the technology is there to kind of pick up these keywords, but, you know, I don't think there's any definite way to interpret it, because at times it can be a contraindicator, sometimes it can be a positive indicator. So that's one issue with it. But, you know, I think this stuff is interesting, but I agree with that. It's been kind of mixed so far.
My question is about the use of open source tools. Could you comment on how much value you derive from the open source frameworks versus internal, and is there a trend in terms of using more open source or using more internal?
Yeah, I mean, I think the internet technology stack is much more based upon open source than the sort of the technology stack that's classically used in bricks and mortar businesses. So we lean towards the internet technology stack, and we lean towards lots of open source products. There's challenges. This is back to the cultural issues of introducing these sorts of things in firms that you know, where the priorities are make the trains run on time, keep it secure, and maybe catch up with technology. And so if you're trying to if your first priority is to stay up with technology, it's a slightly different approach. And I certainly leverage open source.
I agree with Michael. I don't have much to add, except we've seen a couple people saying, I want to use this one, someone else wants to use that one, and factions have developed, but not much else to add.
I think that's a great question, and it ties into the question I was asked earlier about, you know, systems deployment. If you're down in the trenches on the development side, and you're doing deep learning or reinforcement, whatever you're doing, and you're using, and I'm just going to throw TensorFlow out there as an example, it's incredible how fast TensorFlow is advancing. And so this isn't the kind of thing where I've got, you know, I've got a big corporate infrastructure where we're still using, you know, Windows 7, right? And some people may have Windows 10 by now or something. TensorFlow, which is basically the backbone of, you know, the AI world at this point, there is a new release probably every 4 to 5 weeks at this point, and they're not trivial. There are massive advances going on. They're basically doing their best to put PyTorch out of business at this point, and you know, the changes are big, and the increases in speed are extremely noticeable, and so you're having an almost entire platform changes like every 4 to 5 weeks. So it gets into, you know, I think from your traditional kind of IT manager standpoint, they don't know what to do with this, right? Because you have to have the most recent stuff. And like, you know, Google just came out with their own reinforcement learning package, Dopamine, you know, and doesn't even really work on Windows machines. But, you know, so a lot of this stuff is advancing. It's being developed so quickly that IT departments can't even keep up with it. So that's a big problem from, again, as was mentioned, a security standpoint, from an infrastructure standpoint, from a quality, you know, any kind of testing standpoint. You know, I think the tech companies, the reason they're so good at this stuff is they don't have to worry about everyone's social security numbers getting stolen.
Well, I don't know. I disagree.
Maybe they do.
I disagree
they
with that. I mean,
sell it.
No, I think the big difference is they rewrite code all the time. Whereas lots of the traditional tech, bricks and mortar tech companies are programmed to not rewrite code. But you know, I think there's equal risks, and both with, you know, runaway automated algorithms as well as with you know, personal identifying information, but it's a slightly different strategy. And the thing is, if you're an internet company, if you're not up with technology, you're dead. If you're a traditional bricks and mortar business, you know, there's this perception. There's been this perception that there's plenty of time. But if you superimpose that on exactly what you describe, a rapidly changing technology, the gap becomes enormous. And so, you know, so what we do is we do all of our stuff in the cloud. We basically have our own set of you know, because all the rest of the stack is, you know, the IT organization, we just stay away from it. Basically, go and do our development separately. And you know, but I understand that there are all sorts of issues. But the thing is, you can't trade off the moving fast. You know, move fast and breaks things. That's what the motto was at Facebook. And you know, obviously you just need to do it in a sandbox enough environment that's not going to affect your production process.
Yeah, that's no, I totally agree. I mean, that's what everything we're doing is moving to the cloud. I mean, it's, you know, TensorFlow is being upgraded every 4 to 5 weeks, but good luck if you were trying to do that locally with a GPU and NVIDIA and drivers and that type of thing. So,
Yeah.
you know, so the whole world is basically outsourcing the problem to Amazon at this point. But it's an interesting problem. I guess my point is, you know, it's regardless of what you think, the platforms are developing very quickly, and I don't think you've ever seen anything like this. You know, when was the last time someone made a major advancement in multiple regression, right? So, so it's very interesting to see.
I think we have time for one more question.
I think so far we have discussed how to attract talent, and we also discussed the tools. What about data strategies employed at your firms?
What strategies?
Can I just, was that data strategies?
Yes. Data
Yeah.
Oh.
Yeah, I have a perspective. I mean, for us, it's something we've been struggling a little bit with, but it's absolutely crucial, and we have a number of tech people focused on that, trying to store data, and it's also more than just storing data. It's making sure you have all the right data. It's all queryable. It's all scalable, and it's all point in time. From our point of view, that you've got all that history that you can go and interrogate and make sure that you're not machine learning on 2015 data and, you know, saying here's my returns on 2008 using 2015 machine learning. So for us, it's absolutely crucial. We're spending a lot of money, as these gentlemen said. You know, we're kind of outsourcing it to the cloud as well. But I think that's actually, from my point of view, it's the heart of everything you're doing. If you don't have a data strategy, it becomes very difficult to get everything machine learning scalable, because that's the heart of what you're doing.
Yeah, I would just add that, again, the challenge with the traditional bricks and mortar approach is I would just constantly tell them, don't overthink it. And people are used to, gee, you know, what's the schema? How are we going to load this? It's, no, we're just going to load it. You know, we're just going to load it, and we're going to put it in an infrastructure so that you can actually query it any way you want. And, you know, and I think that, you know, sometimes there's too much thought put into, well, how am I going to organize it? You know, what's going to happen here, and so on. I think that you need to be able to move large amounts of data quickly, and you need to be able to get some descriptive statistics and do some analysis and figure out what it says, and so you know. But as Peter Norvig says, you know, if you have sufficient data, then the algorithms can actually be a lot simpler. And I think in many cases, and I also think you have to have lots of creativity about the way you think about how to use data. Lots of folks are taking data and saying, well, let's just sum up all the transactions every day for 13 weeks and try to regress it against revenue. And I think that's really not a creative way to think about very granular information. So I think you have to be able to retain as much data as possible, and you have to be able to make it as accessible in as many ways as possible.
Yeah, it's you know, this is all driven by data. It's not magic. Now, reinforcement learning is not so much data-driven as, say, a deep learning model. But it's, I think that as people migrate to the cloud, a lot of these legacy problems go away as long as it's done correctly. You know, finance is an interesting, or banking in general, I think, is an interesting industry. You know, I think a lot of people to this day still have, you know, old servers from the 70s, you know, written in COBOL, right? So as you go away from that entire infrastructure and it goes to the cloud, I think that's going to be, you know, it's going to be it's going to be make the efficiency rise that much more, you know. And so there are a lot of things kind of coming together here, and that, you know, the data is going to be easier to use. You're going to have everything in the cloud. You know, the tools are going to be easier to use, and so, you know, the productivity and the efficiency is just going to get better from here, I think.
Yeah. Actually, one further point is also, you know, it's the licensing and the privacy issues and the rights to use is crucial as well. I kind of tend to forget that, but can trip you up at the very end.
Gentlemen, this was fantastic. All good things come to an end, and so does our panel. Thank you very much.
Thank you.